Hello guys, welcome to Azure Load Balancer series. In this video, I'm going to speak about what is Azure Load Balancer, why do we need to use an Azure Load Balancer, types of load balancers, and load balancing component. So let's get started. Azure Load Balancer is a layer 4 component in OSI model. Azure Load Balancer is not a proxy, it is just a component which forwards the traffic from the client to the backend pools. It is a single point of contact for the clients. Azure Load Balancer distributes the new inbound flows that arrives at its load balancer frontend to the backend pool instances according to specified load balancing rules and health probes. The backend pool can either be a VM or a VMSS instances. So why Azure Load Balancer? Azure Load Balancer is used to provide high availability and high scalability for your applications. There are two types of Azure Load Balancer available in market. One is public load balancer, another one is internal load balancer. Public load balancer are generally used for public facing applications. Internal load balancer are used for the application which are not exposed to internet. Let's take a typical example over here. In this diagram, we have two applications. One is web application and another one is a SQL application. The web application are exposed to internet and we have three servers deployed which needs to be load balanced. Similarly, there are three SQL servers which are not exposed to internet, and in order to load balance those SQL servers, we use an internal load balancer. The key difference between the public load balancer and the internal load balancer are the front-end IPs which are used. For the public load balancer, we use the public IP address as a front-end, and for the internal load balancer, we use an IP address from the subnet in which the internal load balancer are deployed. Let's take a look into the load balancing components. There are 6 load balancing components available. The first one is front-end IP configuration. You can have multiple front-end IP configuration for the load balancer. The front-end IP can either be a public or a private IP address based on the load balancer type that you choose. Similar to front-end IP configuration, you can have multiple backend pools for a load balancer. You can have a standalone VM, a VMSS, or VM which are part of availability zones or availability set as a part of backend pool. The next component is health probes. The health probes are used to check the backend resource health. Load balancer used to send continuous probe to the backend on the defined health probe port to check the availability of the service on the port. If the health probe fails, load balancer takes the VM or resource out of rotation so that load balancer maintains the high availability of the services which it is load balancing. The next component is load balancing rules. You can have multiple front-end IP configuration, multiple backend pools, and multiple health probes. So this is a component which binds all these three components together. The next component is inbound NAT rule. Inbound NAT rule is used to translate the front-end IP address and port of the load balancer to the private IP address and port of a VM. Unlike load balancer rule, the inbound NAT rule doesn't depend on the health probe. It just forwards the traffic. It doesn't check whether the backend service is running on the specified port or not. It just forwards a packet to the backend VM on the specified IP and the port. The next component is outbound rules. The outbound rule is a component which is only available in standard load balancer. These outbound rules are used in a scenario where you have a VM behind an internal standard load balancer and the VM doesn't have a public IP address. In order to enable outbound connectivity for the VM which is behind an internal standard load balancer which doesn't have public IP address, outbound rules are used. Thank you for watching this video.